Welcome everyone. So the next problem is on the planning. We will consider factory planning. An engineering factory makes 7 products on the following machines. We have 4 grinders, 2 vertical drills, 3 horizontal drills, 1 borer and 1 planer. Okay, we have grinder, vertical drill, horizontal drill, borer and planer. And each product yields a certain contribution to profit and requires a certain production time in hour. We will give this information in the table. A dash indicates that a product does not require a process. Okay, and this is a table. You see that the product 1 has contribution is contributed to profit 10, and the contribution to profit of product 2 is 6, for 8 for product 3, for product 4, 11 for product 5, 9 for product 6 and 3 for product 7. And in order to produce product 1, you need 0.5 hour or 30 minutes, half an hour of grinding machine, and 0.1 hour vertical drilling, and 0.2 horizontal drilling, and 0.05 boring. Okay, and you can see that we don't need planner for the product 1 in order to make product 1, and for product 2 you need different hours of machine. We need grinder, we need drilling, vertical drilling, we need borer, and for product 3 we need only horizontal drilling and planer. And in case of product 4 we need vertical drilling and boring, and product 5 needs grinder, boring and planning, and for product 6 we need grinding, vertical drilling, for product 7 we need grinding, horizontal drilling, boring and planning. Based on this information, assume that we are at January, we call in the present month, and the 5 subsequent months. Certain machines will be down for maintenance, of course, and these machines will be as follow. For example, in January, 1 grinder will be down for maintenance. In February, 2 horizontal drills need maintenance, so they will be down. And in March, 1 borer needs maintenance, and in April 1 vertical drill needs maintenance, and in May 1 grinder and 1 vertical drill need maintenance, and in June 1 planer and 1 horizontal drill need maintenance. They are making marketing limitations on each product in each month. These are given in the following table. This table. It's a marketing limitation, okay, for each product. For example, for product 1, the market or requirement it's 500, February 600, in March 300, April 200, May will be 0, and in June 500. Okay, and you have this kind of information for product 2, product 3, product 4, product 5, 6 and 7. Okay, additionally, it is possible to store up to 100 of each product at a time at a cost of 0.5 per unit per month. There are no stock at present. Okay, assume that at present we don't have any stock. Okay, and of course each month we can produce more than the requirement of demand of the market, and then we can store it up, okay, but the maximum is 100, okay, as mentioned. Okay, so but it is decided to have a stock of 50 of each type of product at the end of June, okay. And finally, at the beginning we don't have stock, we have no stock, but at the end of June we need stock, okay, 50 of each time. And the factory works 6 days a week with 2 shifts. Yeah, one shift is 8 hours, okay, for each day. So 2 shifts, 8 hours each. Okay, so the objective is, well, the factory want to know when and what should the factory make in order to maximize the total profit. Well, from the given information, you can treat this problem as multi-period optimization, right? Because we deal with different period. We have 6 periods, right? First month, second month, yeah, January, February, and yeah, to June, right? And you have what is it? Information regarding the stock, right? At the beginning, we don't have stock, and well, it's possible to store each product for 100, right? And for 100 units, and then well, at the end of June we need 50 of stock, all right? We have to satisfy 50 units for each product. Okay, so apparently you can treat this problem as multi-period optimization. Alternatively, well, you can formulate this problem different way. Using different strategy, and of course you end up with different type of optimization problem. Well, I will show you how to formulate the problem as multi-period optimization first. Okay, we formulate this problem as multi-period optimization, right? And what is our objective? Our objective is, well, maximize the profit, maximize total profit. Okay, this is our objective function. So you have to write down the objective function first. The objective function is a profit. Okay, you have to declare your profit. And what is a profit? Profit is, what is it? You can look at the, well, contribution, right? Profit contribution of each product, right? So, well, let me show you here again. I'm going to write down the contribution of the, to the profit from each product. We have product 1, the contribution is 10, right? For product 2, the contribution is 6. For product 3, the contribution is 8. And for product 4, 11 for product 5, 9 for product 6, and 3 for the last one, product 7. So you have to formulate the objective function, the profit, as a function of our decision variable. So let us declare our decision variables. Well, the decision variable is the parameter we want to optimize. We want to find, right, our design variable or design space. And the objective of this problem is we want to maximize the profit by design when and what should the factory make, right? So our decision variable can be, well, the product, we can write product I, and for J, I mean Pij. All right, so the amount of product I we produce at J month. Okay, so in this case, of course, I is product, right? So I can be 1 to, no, not 6, 7. Yeah. And what about J? J is month, right? The month that we produce, right? When we produce, right? So J can be 1 to 6. Okay, so we have a matrix P, which is 7 to 6, right? 7 by 6. So totally, it's this variable consists of 42 variables. All right, but to make things simple, we write Pij, which is only one variable, but that variable is a matrix, of course. So what to do? The contribution of each product is constant, right? Constant through the time. No matter we produce the product at first month, we sell the product as first month, we sell the product at the second month, of course it will be the same, right? But remember that we have two different variables. The first variable P is our produce, right? Produce product, product we manufacture, but we don't have to sell it at the same month. I mean, if we produce the product in January, we don't have to sell it in January. We can keep it, right? Because there are storage. We can keep them in the storage. Some of them, of course, not all of them. Some of them in the storage, and then we can sell it in February, March, April, May, or June. Of course, product 2, product 3, product 4, 5, 6, 7, the same, all the same. Okay. Also, if we produce some product in February, of course we cannot sell it in January, but we can sell it in February or March, April, May, June, whatever. All right. So what else? We have variables of Sij, where Sij is represent the product. Okay, the product from I can be 1 to 7, right? The product 1 to product 7 we sell in each month. All right, so it can be I the same, I starting from 1 to 7, and J starting from 1 to 6. Okay, what else do we have? We have a storage. Let me use T. T can be I and J again, and T is a storage of a stock of each product at the beginning of each month. So we have again Tij, which is 1 to 7, J is 1 to 6. All right. Okay, so what about the objective function? The objective function is a function of sale only, right? Because we don't have the cost. We don't have element of cost here. We have element of revenue, and of course not just revenue. It's a contribution to profit directly. So our objective function we want to maximize. Let me write profit first. So our profit is a function of what? Because we know that the contribution of product 1 is 10, right? So amount of product 1 we sell at, well, starting from January to June, yeah, it's summation of P1, right? P1J, and J must be vary from 1 to 6. And what else? We have product 2. Product 2 is contribute to profit about, yeah, it's 6. The contribution to profit is 6. So J1 to 6 again, and not 1 becomes 2 now. 2J, right? And then we have product 3, which contributes to the profit is 8. The contribution is 8. So J1 to 6 again. Oh, wow, I forgot P here. So it should be P here, right? 3J, okay. And we have product contribution of product 4. I don't have space at the end of the line, so well, I begin the next line then. Yeah, 11. We have summation of J to 1 to 6 of P 5J and plus 9. Summation J from 1 to 6 again of P 6J. And the last one, product 7, the contributions is only 3. And summation of J from 1 to 6 of P 7J. Okay? And this is the function of our profit. So we have decision variable already, and we have objective function already. Now, well, we will look at each constraint. Yeah, the most important one is all the P, right? Pij, and what else? Sij. Oh, sorry, I forgot that. Yeah, this one should not be P, sorry. Yeah, they must be S. Sorry, not P. Why it is not P? It should be S. Yeah, we have decision variable, well, 2, 3 decision variable, right? P, S, and T, right? For T, of course, it doesn't involve here. It is stock, and of course, it is not finished yet. Yeah, so sorry about that. Yeah. Well, we have P, which is production, right? Production, all right. And anything we produce at each month, of course, we don't have to sell them at that month. We can sell it later. But as represent the amount of each product we sell at each month. All right. So this should be S because it is a profit, right? The contribution to the profit. So it should be the product we sell at each month, right? So the sale of each product and each month contribute to the profit. And yeah, and this one is not finished yet because this is only revenue or profit from making and selling the product. But remember that we have cost on the storage, right? On the storage, well, for example, yeah, from the information given, it is possible to store up to 100 of each product at a time at a cost of 0.5 per unit per month. Okay, so anything you store in the storage, it costs 0.5 per unit per month. Okay, so if you sum up all I and J in the storage, Tij, right, and you times it by 0.5, okay, it will be cost for the storage. All right, it is a storage cost. So let me explain again. The first part involves the profit. Okay, well, it related to what is it? Fabricate or manufacture product, each product in each month, and then you sell it. And for the second part, this part, okay, it is the cost for storage. Okay, storage cost for each product we store in the storage per a month. So it should be like this. Okay, so you have to time up with 0.5 because for one unit of the product you keep it in store in a storage. All right, for 1 month it costs 0.5. Okay, so it should be complete for the objective, right? So the next one, each decision variable, for all decision variable, they must be greater or equal 0. This is really important. You cannot manufacture a negative unit of product, right? Also, you cannot sell as negative unit. Also, you cannot store as a negative unit, right? So this is important. The next one is, at the beginning Ti1, okay, at the first month, because T is the stock at the beginning of the month. So at the beginning of the first month, at the beginning of January, each product we have storage of 0. Okay, so now we move to the constraint, equality constraint regarding the period, right? The monthly period optimization. What in the store, for example, we consider the first month first. At the beginning of the first month, we have Ti1 in the stock. We produce Ti1 at that month. Okay, it must be our sale at that month. Okay, plus what in the stock. At the beginning of next month. I think it's clear by what we look at the mass balance. Okay, in terms of mass balance, it is clear what in the stock, what we produce. Some summation of what in the stock and what we produce must be equal. What we sold. What we sell in that month and what remains in the stock. Okay, and we have the same similar, the same analogous to analogy with this one. We Of course, I can be product 1, product 2, product 3, yeah, to product 7. And it's true for the second month too. Plus, what in the stock? You know that in the stock, it is required that we have a stock of 50, right? So it should be 50 here. We cannot write TI7. Oh, sorry, we have 6 months, right? So oops, sorry, I mix up this other thing. Okay, it should be 5 first, then we can have 5, okay, 6 first, okay, and then the last one in June. Plus 50, okay, 50 is required to stock 50 of each type of product at the end of June. So we must maintain 50 for each product. And the next one is the market demand. For the demand, we have demand for each product at each month. So you have to maintain the demand. So it's possible to satisfy the market demand. As 1 must be 500. If you have a contract to deliver 500 units of product 1 at the first month, and this one can be lesser or equal. In the case you don't have a contract, but of course you know that the stock the demand for the market is 500. You can you can sell it, but not greater than the demand of the product 1 in the first month. But most of the time this should be, for the factory, this should be equal, because you have some kind of contract, right? So S1 for the second month is for the second month, for February, it's 600, and you have S1 for the third month as 300. You can look at the table given in the equation, and then just just formulate the equality constraint based on the number of the demand of the market demand. For the fifth month it can be 0, and for June, product 1 for June is 500. Okay, again we have product 2 for the first month is 1000, right? We check again with the table given right in my slide. This can be, must be 500, 600, 300, 100 and 500. Okay, and this is the for 6 months. All right, I write some of it, but well, you can complete it later by yourself. $300, $200, right? $400, $500 and $100. Okay, we still have to write down the equality constraint on market demand for product 4, 5, 6 and 7. Okay, you can do it by yourself. The next set of constraints are availability of machine. For each month, for each month you have a plan for maintenance of each machine, right? So each day we have, the factory works for 6 days, right? 6 days for each month, work for 6 days. Six day and 2 shift. One shift is 8 hours. Okay, so 1 month is 4 weeks, right? 4 weeks, 1 week is 6 days. Okay, and each day you have 2 shifts too now, and each day we have 8 hours. Okay, so each month we have availability of machine. Totally 384 hours. Okay, so let me look closer for the availability of the machine. You know that for January, one grinder will be down. Grinder down, right? Down. So we have 4 grinders. Totally we have 4 grinders. Alright, this is just for January only. We have 4 grinders. We have 2 vertical drill. We have 3 horizontal drill. We have 1 borer. We have 1 planer. Okay, planer. So you see that in January we have 4 grinders, but 1 will be down, so we have only 3. And each machine we have 384 hours. So totally in January we have only 3 grinders, and each grinder we have 384 hours. That is for grinder. And for the vertical drill, it should be 2 times by 384 hours. And of course for horizontal drill we have should be 384 hours. Okay. Okay, now so you see the availability of each machine, right, for the first month. Now we look at the requirement of the machine in order to produce product 1, 2, 3, 4 to 7. Yeah. So from the table you see that, well, for product 1 first, grinding, yeah, we need 0.5 hour, all right, of grinding for production of product 1 in the first month in January. And then we also need grinding to produce product 2, right, to 7.7, right? So we time 0.7 with the amount of product 2 produced in January. Also we need 2.3 hours to produce 1 unit of product 5 in January. We need 0.2 hours of grinding to produce product 6 in the first month. And then finally, for product 7, we need 0.5 hours for the production. 0.5 hours for production of product 7. So you see that availability of the grinder we have is 3 times 384. So this number should be lower than 384. Okay. Now we look at the vertical drilling. For vertical drilling, we need it for product 1 and we need it for product 2. What else? We need 0.3 for product 4, and we need 0.6 for product 6. Okay, and this number must be smaller than 2 times 384. Okay, and the next one is horizontal drilling. For horizontal drilling, we have we need 0.2 for product 1 and 0.8 for product 3 and 0.6 for product 7. Okay, and this number must be lower or equal 384. All right. So for boring, we need 0.05 P11. We need 0.3 or 0.03 for product 2. We need 7 for product 4. We need 0.1 for product 5 and we need 0.08 for product 7. Yeah, and this number should be smaller than 384. Okay. And the last one for planning, we need 0.01 for product 3. We need 0.05 for product 5. We need 0.05 for product 7. And this must be smaller than 3s4. Okay? And this is the availability of all machines required for each product. First, for February, we know that 2 horizontal drills will be down. Okay, so we have floor grinder. Of course, we have floor grinder. Right? So it's 4 times, yeah, and 2 vertical drill. We have 2 drill, right? We have 3, right, horizontal drill. This is what we have, right? But of course it will be down for 2 of them will be down, and 1 borer, 1 planer. Alright, so we have but this one we have 384 because 2 already down, so we have only 1, right? And this would be 384. Okay, and this is this metric represent availability of all machines in February. So you see that, well, it's analogous to this one, because on the left hand side is very similar, because machine required for each product, right? But the difference is on the right hand side. This number will be changed for February, right? Because now we have 4 in February. We have 4 times 384, and for vertical drill, of course, it's exactly the same. But for horizontal drill, we have only 1, right? This become 1 times 384. For borer and planer, this is exactly the same. All right. And on the right hand side, you have to change this to February, right? Change everything to 2, and change J to 2. Okay? Then you can formulate the constraint for February. And the next one, for March, you know that for March 1 borer will be down. So, for March we have, I'm going to write it here. For March 1 borer will be down, right? 1 borer will be down. So for grinder we have 4 times 384. For vertical drill we have 2 times 384. And horizontal drill, of course, we still have 384. No, it's not 3. We have 3, so it should be 384. But we don't have borer, because borer will be down, so we have 0 borer. And what about planer? We have 384 planer. All right. So Then we can formulate the availability of the time for each machine, right? Availability for machine. And for April, one vertical drill will be down. So, well, using the same way, you can formulate the available machine for April. Also May and June, you can do it. By combining all the objective functions we formulated, also decision variables and constraint, all the constraint we formulated, then of course we can write down the optimization problem, of course. Yeah, do it by yourself again, because it's quite tedious for this problem.